Okay, so today we're going to go over section 10.1 and we're going to do a little review of how to work with percents. Okay, so to begin, I'd like you to arrange the following fractions in ascending order. So if you could pause the video and write these fractions in ascending order, and then hit play once you're done with that. Okay, so the difficulty of arranging these fractions in ascending order is that we have them written in using different denominators, and it makes it kind of hard to compare. So what we can do is we can write each of the fractions with the same denominator. So we have 3/4, we have 1/2, we have 5/8, and 3/2. Now the fundamental rule that you learned in arithmetic is that you can change the way a fraction looks without changing its value by multiplying the numerator and denominator by the same number. So we have to think of what number can we turn each of these denominators into. And another common way of looking at that then is what is a common multiple. So your denominators are 4, 2, and 8. And the multiples of 4 are 4, 8, 12, 16. The multiples of 2 are 2, 4, 8, 2, 4, 6, 8, 10, 12, and the multiples of 8 are 8, 16, 24, 32. These are the multiples, right? And so you're looking for a number that is on both lists, right? And so if you look, you will notice that 8 is on all the lists, not both, all of them, right? And so your least common multiple is 8. Right? And so then what we want to do is we want to multiply the numerator and denominator of each fraction by whatever it takes to make the denominator 8. So for this one, we multiply the numerator and denominator by 2. And now this is 6/8. This one we multiply the numerator and denominator by 4. And this is 4/8. And this one is already has a denominator of 8, so we just leave it alone. And this one we multiply the numerator and denominator by 4. And you get 12/8. Notice that when you multiply the numerator and denominator by the same number, 2/2 is 1, 4/4 is 1. You're just multiplying by 1. And when you multiply a number by 1, you don't change its value. So 3/4 has the same value as 6/8. 1/2 has the same value as 4/8. 3/2 has the same value as 12/8. But now all the denominators are the same. And it's easier to write these fractions in order. So in ascending, the smallest one, we are now just comparing the numerators because all the denominators are the same. 6, 4, 5, and 12. So 4/8 is the smallest fraction. And then 5/8. And then 6/8. And then finally 12/8. 4/8 was the same thing as 1/2. 5/8 was already there. 6/8 was the same thing as 3/4. And then finally 12/8 was the same thing as 3/2. And so there are the fractions written in order, right? Now, didn't tell you how to do the problem. So another approach could have been to write your fractions as decimals, right? Because 3/4, another way of looking at 3/4 is it's saying 3 divided by 4. So you are allowed calculators in this class, but let me just remind you of how you divide 3 by 4, right? So one way of dividing 3 by 4 is by you're dividing, whatever you're dividing by goes out here. Whatever you're dividing into goes in here. Now 4 obviously does not go into 3 a whole number of times, so we start working with the decimal part. Bring the decimal point straight up, add a 0, And now 4 goes into 30 7 times. 7 times 4 is 28. Subtract, and you get, you have to borrow. This is 2, this is 1, this is 2. And so then you have to keep adding another 0 because 4 does not go into 2. But 4 goes into, we can bring down the 0. 4 goes into 25 times. And then 5 times 4 is 20. And we subtract and we get 0. And so then once we have no remainder, then we're done. So 3/4 is the same thing as 0.75. You can just use your calculator, but 1 divided by 2 is the same thing as 0.5. 5/8, you can just use your calculator. 5 divided by 8 is 0.625. And 3 divided by 2. Here, 2 does go into 3 one time, and you have a half left over, so that's 1.5. And so then again, now it's very easy to put them in order. The smallest one will be the 0.5. And then the 0.625. And then the 1.5, I'm sorry, the 0.75. And then the 1.5. Okay. Now, one of the things that people hate most in math when they're first working on math is fractions. Fractions have a lot of rules. You can only add fractions if they have a common denominator, but when you go to multiply fractions, you can multiply straight across. When you divide by fractions, you multiply by the reciprocal. A lot of rules that make this challenging for people. And so people don't like fractions. So writing your fractions with the common denominator, challenging for some people. People prefer decimals to fractions because then you don't have quite so many rules. But now you've got these numbers that you're not that familiar with these decimals. So if the next up after fractions, people would rather deal with decimals than fractions, but they don't like decimals that much either. They prefer nice whole numbers, right? So we're going to want to compare things like this from time to time. And so we're going to come up with a way of making it more presentable, easier to digest. So exam 1 had 80 questions. You answered 76 correctly. Exam 2 had 125 questions. You answered 116 correctly. Which test did you do better on? Okay, so now again, this is the same kind of problem that we were having before. Is we have 2 exams, but they didn't have the same number of questions. And so really what we want to compare is not the number of questions that we answered correctly, but the rate at which we answered them correctly. So we want to compare the 2 different rates. And the rate at which we answered the questions correctly on the first exam would be 76 out of 80. And what you see here is a fraction, right? Exam 2 had 125 questions. You answered 116 correctly, so the rate at which you answered the questions correctly was 116 out of 125. And so these are rates, and you'd like to see which one of these rates is higher, which has the higher rate. And again, so we have these fractions, and the last thing we want to do is we want to write them with a common denominator, because that might be a little bit confusing. But again, we could turn them into decimals. 76 divided by 80 is 0.95. There are a couple things wrong with this. I mean, not wrong, but just not as intuitive. We used to have a ratio. We were answering questions correctly at 76 for every 80 asked. And over here, we just have a decimal. So that kind of doesn't make it look like a ratio anymore, even though it is. Same thing, we can take the 116 and we can divide it by the 125, and that will give us 0.928. And now what this does do is this does make it look, I'm sorry, this does make it easier to compare. You can see that the 0.95 is bigger than the point 0.9, the 95 hundredths is bigger than the 928 thousandths. And that's because although they have the same tenths place, this one has a larger hundredths place. We have 5 hundredths here, we only have 2 hundredths here, and then we're done. We could tell that this one's better. But again, two problems with this. One is it kind of doesn't look like a ratio anymore because you're not, you don't have a denominator, even though there is always a denominator of 1 that we do not write. And so really, you could always write this as 0.95 to 1, 0.928 to 1. The denominators are the same. But you know that looks like a funny ratio. How did you answer questions at a rate of 0.95 for every one? So what we would like to do is get a common denominator that makes this look more like a ratio and makes it easier to compare. And again, what we can do is we can multiply the numerator and denominator by whatever we like, and we're going to multiply the numerator and denominator by 100 because working with 100 is really, really easy, right? So when you go and multiply 100 times 0.95, all that ends up happening is you just move the decimal point over 2 places. So the 0.95 becomes a nice whole number, 95, and the denominator becomes 100, right? And here we're going to do the same thing. We're going to multiply the numerator and denominator by 100. Okay, but when we do that, again, the decimal point moves over 2 places, 92.8, and in the denominator we get 100. And now this top one tells us that we answered questions at a rate of 95 for every 100 asked. This bottom one tells us that we answered questions at around 93 for every 100 asked, or 92.8 for every 100 asked. Now we could do this as 928 to every 1,000, but then the denominators would be different and they'd be more difficult to compare. Now, since people don't like looking at fractions, what somebody said was, okay, when we have a denominator of 100 and we're looking at ratios, rather than writing it as 95 over 100, we're going to write it as 95 per cent. Cent, century, century, 100, so per 100. So when you see a percent, 95%, that means 95 per 100, right? And so likewise here, we're going to write this as 92.8%. And the sole purpose of this is just so that it's easier to process, right? Now you're just comparing these two more whole number looking like things, 95 and 92.8, and not the 76 over 80 or the 116 over 125. And then we can compare them. They're both, the denominators are both the same. They're both per 100s, and this one's obviously better. Okay, so make sure you answer the question, which test did you do better on? And the answer is test 1. Test 1, you got a 95%. Okay, so again, this should all be reviewed. We're just going over it again because I really need you to be able to work a little better with percent. Some of you have expressed difficulty with percents, so let me go ahead and go through this and hopefully clear this up some. Again, I'm not just going to go over how to do things, but try and explain it a little more, so you can understand it, not just so that you can do it. And that's what I try to do, is try to explain things, not just how to do it, but why it works that way. And a lot of it is really just notation. That's what I'm telling you in this slide. When you see X%, that's really just a fraction that means X over 100. And so X% is a ratio of X to 100, right? That's all it is. So write the ratio with a percent symbol, right? So go ahead and Try that. Pause the video. Okay. So I'm going to go through this step by step. Again, um, not trying to just go over the technique, but trying to get you to understand what's going on, right? This is just 7/8, 7 divided by 8. We want to write this with the denominator of 100, right? And so what we can do with the calculator is very easily write this as a decimal, 0.875. And again, anytime you have a number, you could always write it as a fraction over by writing it over 1, right? And so this 0.875 can be seen as 0.875 over 1. Write the ratio with a percent symbol means we want the denominator to be 100. So we just multiply the numerator and denominator by 100. And then what that gives you is 87.5 over 100. And then we, just like the previous slide says, right? X percent is the same thing as x over 100. So x over 100, we just rewrite as x percent. We're just using the formula backwards. So 87.5 over 100 is 87.5%. Okay. So that's going step by step. I don't expect you to do that every time. You can do that as often as you like, but I just wanted to explain to you why it works this way. But here's basically what, if you do enough of these, another common theme in math is to look for pattern recognition, get more comfortable with, do it quickly, right? And so then you take your fraction, you write it as a decimal. Once you have the decimal point, when you multiply the numerator and denominator by 100, that just moves the decimal point over 2 places and you get the 87.5. And then instead of writing 87.5 over 100, you write 87.5%. So you're just going to skip a couple steps. So try this next one. Again, pause the video, try the problem on your own. You don't have to do the long division by hand. You can do that with the calculator. And so 38 divided by 40 is 0.95. And now I'm going to skip the step. We're just going to multiply the numerator and denominator by 100, which is going to give me a 95 over 100. And I don't write the over 100. I just write 95%. Okay. So what percents are is their rates or ratios, right? And so on an item that cost $76, you paid $6.46 in taxes. What is the tax rate? Write the answer using a percent symbol. So we are paying $6.46 in taxes, and we're comparing that to what the item cost. The item cost $76. You are paying taxes on your on the cost of your item, and so then now we have a ratio. $6.46 to every $76, and we can divide that with the calculator. $6.46 divided by $76, and the calculator gives me the decimal answer 0.085. But this is a perfectly valid rate, but that's not the way we typically see things. The problem tells you to write your answer using a percent symbol. So then multiply this by 100 and you get 8.5 over 100, but we, instead of writing the over 100, we just write a percent symbol. Okay. So we need to be able to go forwards and backwards, and you'll see why in just a little bit. Write the ratio as a decimal. So 86%, right? The percent just means over 100. So this is just 86 over 100. And then 86 divided by 100. And let me go ahead and do that for you, long division one time. to show you why this works and why we used 100 as our common denominator. Okay, so 86 divided by 100, we're dividing by 100, means that the 100 comes out here and the 86 goes over here. 100 doesn't go into 86, so we put a decimal point and then go straight up and we start adding zeros. But 100 does go into 860, and 1 goes into 8 times. And then 8 times 100 is 800. And then we subtract, and you have 60. 100 doesn't go into 60, so we have to add another 0. And 100 does go into 100 6 times. And then 6 times 100 is 600. And when we subtract, we get 0. And if you'll notice, when you did this division, you have the exact same digits as you had right here, right? The exact same digits. It's just that the decimal point is now moved over two places to the left. The decimal point used to be right here, and the effect of all of my work up here was just to take this decimal point and move it over here, right? So that's one of the really nice things about working with 100. It's very easy to multiply by 100, and that should make sense. When you multiplied by 100, you moved your decimal point to the right 2 places. And so then, since division is the opposite of multiplication, so when you divide by 100, you just move the decimal point over 2 places to the left. And so then this is 0.86. And we no longer have to go through that step. We identify the decimal point, there it is, and we just move it 2 places to the left, 1, 2. And so you get 0.15. Now, you have to be really careful with expressions like this. That's 6%, because people seem to run out of places to move the decimal point. But remember, putting a 0 out in front of the number doesn't change the place value, doesn't change the value at all. Putting it behind it would make it 60. Now, if we move the decimal point over 2 places, what we get is 0.06. And another place where people get confused is when they have a percent that is already a decimal, right? Again, all this means is 0.01 over 100. That's what the percent symbol means. And whenever you divide by 100, you just move the decimal point over 2 places, right? And so then, since it's right here, you go 1, 2, so you're going to have a total of 1, 2, 3 zeros, 1, 2, 3 zeros, and then the 1, and the decimal point goes right here. It used to be right here, it goes moved over 2 places, and you should get in the habit of putting the 0 in front of the decimal point, right? And so then there you go. Okay. Express each of the following percentages as a decimal. Again, pause the video, try this on your own, and then hit play and see if you were able to get that okay. So again, 8.75% means per 100, means that's being divided by 100. To divide by 100, you move the decimal point over 2 places, 1, 2. And so you will get 0.0875. The digits don't change. Okay. This one, 4 and 1/8, really means 4 plus 1/8. So one way of doing that is to write the decimal representation of 4 plus 1/8. So you can just ask your calculator, what is 4 plus 1/8? And my calculator tells me it's 4.125. That should make sense. I had 4 wholes and then an eighth, so I still have my 4 wholes, and the eighth is written as a decimal, 0.125, 125 thousandths. And this is still the percent. We haven't changed it. And then the decimal point moves over 2 places, 1, 2, and we end up with 0.04. 1, 2, 1, 2, 5. Sometimes we deal with fractional percents. This is 4/5 out of every 100. And there's still nothing wrong with that. You will see this from time to time when you're seeing advertisements. 2 1/3% or something like that. So 4/5 percent, well, we can first write the 4/5 as a decimal. That's 0.8. And since it already looks like a percent, this is where people get confused, right? But the percent symbol is still there, right? So this is not written as a decimal because we still have the percent symbol, right? And so then we move the decimal point over 2 places. So we need an extra 0 there, and it's going to move 2 places. And we have 2 zeros before the 8, and then no more decimal point. So we're on to the next problem, getting comfortable with percents, right? On a test worth 80 points, you earned 74. What percent did you earn on your test? Okay, so again, what we want to compare is how many points you earned and how many points were on the test, right? So we want to compare the points earned to the test, to the points that were on the test, right? And so in more general situations where it's not points on a test, what we want to compare is the percentage. Those are the portion of the whole that we're interested in, the percent that you answered correctly, to how many points were on the test, right? And I'm going to call that the whole. Um, you could call it the base. You can call it something else, right? And so then you're going to compare the percentage, how many points you earned, to the whole. And when I do that, that will give me the percent. So this is the basic percent formula, right? So you earned 74 points, and there were 80 points possible. And so when we calculate this on the calculator, 74 divided by 80 is 0.925. So this is the ratio at which you answered your questions correctly, 0.925. Okay, but again, since the question asks what percent did you earn on the test, we're going to write this as using the percent symbol. And so then we get 92.5%. So the rate at which you answered questions correctly was 92.5 per 100 questions asked. You would answer 92.5 per every 100 questions that you were asked. Okay. Now, so here's some vocabulary that's going to be slightly different than your book. People always interchange percentage and percent. The way I keep this straight is the part of the whole that you are concerned with, what you are comparing to the whole, that's what I'm going to call the percentage. However, whatever your base that you're comparing to, I'm going to call that the whole. And once you get your final answer, right, with your percent symbol, we're going to call that the percent. This may be different than what you've seen before. This is going to be what I'm going to use throughout this class, and this is how I would like you to look at things. Another common thing is you need to be able to look at things in different ways and not just, well, my teacher told me this, and just be stuck with one way. At the end, maybe you like your previous way better, maybe you like my way better, but at least you thought about it and processed it, and that's part of the learning process. Okay. So there were 4 different sections of Financial Mathematics 101 offered last semester. In Section A, 31 out of 38 students passed the class. In Section B, 47 out of 56 students passed the class. In Section C, 34 out of 45 students passed the class. And in Section D, 45 out of 52 students passed the class. Compare the passing rate in each section and rank them from best to worst. So compare the passing rates, right? So we want to compare the number of students who passed to the number of students in the class. That's the passing rate. So for A, your rate was 31 out of 38. And for comparison purposes, we want to write that using a percent symbol by dividing the 31 by the 38. So in the context of this problem, the whole represents the number of students that were in the class. The percentage, what we're comparing to the whole, is the number of students who passed. And we compare them by dividing them, 31 divided by 38. And this gives me a decimal that goes on forever. And so we're just going to round it off to the thousandths place. So this is approximately 0.816, which we then can write as a decimal, I'm sorry, as a percent, so that we don't have to look at the decimal, 81.6%. Okay, so now for B, we had 47 out of 56. 47 out of 56. These squiggly lines mean approximately. So 47 out of 56 is 83.9. I'm sorry, 0.839. And then we can write that as using a percent symbol. Just makes it a little easier for people. 83.9%. And then C, 34 out of 45, 34 out of 45, 75.5%. So 34 out of 45 as a decimal, 0.756, and then we get 75.6%. Don't forget the percent. Okay, and then finally for D, we have 45 out of 52. 86.865, which is 86.5%. So you can see one of the usefulnesses of percents. Now you can more easily compare the passing rates, compare the different rates, and also then you don't have to stare at decimals or fractions as much. It's a lot easier to compare. Okay, so compare the passing rates in each section and rank them from best to worst. So you can see that D has the best. And then from 86, we go down to B, which is 83.9. And then from 83.9, we go on to A, which has 81.8, I'm sorry, 81.6%. And then to C, which has 75.6%. So you need to be able to identify when you have a basic percent problem. And when you have a basic percent problem, you can use the basic percent formula. Now, what we did when we were calculating our success rate on our tests and our pass success rate on our classes is we compared the whole, how many points were on the test or how many people were in the class, to the number of points, to the percentage, right? You can call it a part, you can call it whatever you want. I use percentage, even though maybe part would be better because people interchange percentage and percent all the time. But this percentage is really the part of the whole that you're comparing to, the whole. And so then that ratio, when you divide it and rewrite it, forms the percent. Now, when you're trying to find the percent, you should use this form of the formula, right? But if you take both sides and multiply this formula by the whole, then over here the wholes cancel out and you end up with this other formula. This formula is better suited to figure out the percentage, the part of the whole that you were comparing to. So this is the formula, this formula is useful for calculating the percentage. You could do it up here as well. You could do it with this formula as well, but this formula is more useful for that. What you have to first identify is this a basic percent problem? And if it is, then you can apply this formula. Once you apply this formula, your formula has three parameters: the percentage, which is the part of the whole, the percent, which is the ratio, and you'll be able to recognize that because it typically has a percent symbol, and then the whole. And your percentage is just the percent times the whole. So your score on an exam was given as 87.5%. If there were 48 questions on the exam, how many did you answer correctly? Right? So then again, you should read the problem and understand that this is a basic percent problem. You have 48 questions on an exam, so that's obviously the whole. How many did you answer correctly? That's what we're concerned with. This is the percentage. And then the one with the percent symbol is the percent. So then you can go to your formula, percentage is equal to the percent times the whole. And you can substitute in the values you know. You know two of them. 48 is the whole. And 87.5 is the percent. But notice what happens if we do 87.5 times 48, right? So when we do 87.5 times 48, we get 4,200. So on a test with 48 questions, you answered 4,200 questions correctly. That makes absolutely no sense. What went wrong? What went wrong is that the percent it was 87.5%. So that is a fraction, and you forgot the denominator, or I forgot the denominator. I forgot the over 100. And so then what we need to do is include all of it. And so rather than including the percent, we drop the percent here and we write it as a decimal. And so then again, to write it as a decimal, we're dividing by 100, so we just move the decimal point over two places. So you have 0.875 is your percent. And now when we do 0.875 times the 48, our answer is a lot more reasonable. We have a percentage, which in this problem represents the number of questions that we answered correctly, is 42. And that should make sense. There was 48 questions on the test. We got 87.5%, so 42 questions were answered correctly. You wish to leave a 20% tip at a restaurant. If the bill came to $49.75, how much of a tip do you leave? All right. So again, you have to recognize that this is just a basic percent problem, that your whole or your base amount is this 49.75. That is what you're going to compare your tip to. You want to compare your tip to how much the meal cost. So this is your whole. Typically, the percent is easy to recognize because it has a percent symbol. And so then this is your percent. how much of a tip do you leave? So then you should recognize that this is a basic percent problem. You're comparing the tip to the total cost of the meal. And so then that is just the percentage. So the percentage in this case represents a tip. It's not always a number of points. And then the percent is 0.20, and the whole is $49.75. And when you multiply that out, you get $9.95. You wish to tip at a rate of 3/20ths. How much tip? How much is the tip if the bill came to $24.85? So again, this is what your bill was before you left the tip, $24.85. So again, that's the whole, right? And you wish to tip at a rate. Remember, a percent is just a rate. And so in this case, um, your percent was not written with a percent symbol, but you wish to tip at a rate. And you should know that that's what the percent is. It's the rate, right? And so then there's no percent symbol. There's absolutely no need to write a percent symbol. So one way to calculate the tip is equal to the percent, 3/20, times the whole, $24.85. And you can just put that into the calculator. And 3/20 just means 3 divided by 20. And then you multiply it by $24.85. And in this case, we end up with a number that doesn't make much sense in terms of everyday life. So the calculator tells me 3.7275. But we only go out to the hundredths place in money. So we should probably round that up. And since this is an 8, so then we round that up to $3.73. And so that should be our tip. And if you just wanted to, right? So that's what your tip should be. Now, another way to approach the problem is first figure out what is the percent. Three divided by 20 is 0.15. So that's the percent. No need to write it as 15% because we're going to use the decimal of approximation. And so then the tip is still the percent, 0.15, times the whole, times the cost of the meal. And so then we get 0.15 times 24.85, and we get the same thing. It makes no difference. Makes absolutely no difference how you do that. Jefferson Elementary School has 750 students. The Friday before spring break, 22% of the student body was absent. How many students were in the school that day? Okay, so again, you need to identify whether this is a basic percent problem or not, right? So this ratio, the 22%, is the students that were absent, right? So that's not what we're looking for. The question asks, how many students were in school that day, right? So again, we have our basic percent problem. We have our basic percent formula. The percentage is equal to the percent, 0.22, times the whole, 750. So when we do 0.22 times 750, we get 165. But again, you need to make sure that you answer the question And this was not a basic percent problem because it's not what that's not what it's asking. This is the rate at which of the students that were absent. So this is the number of students that were absent, and the problem is asking how many students were in school that day. And so then what we have to do is take the 750 students that are in the school and subtract 165. 585. Here is another approach. The problem tells us that 22% of the students were absent, right? And so then, since a student is either absent or present, if 22% were absent, what percent were present? Right? And so then, since everybody would be 100% minus the 22%, 78%, 22% absent implies 78%, 100 minus the 22, were present. Okay, and so now this is the portion of the whole that we're concerned with, and now this is a basic percent problem. The percentage is equal to the percent times the whole. And when we do 0.78 times 750, we get 585. Same answer. Two different ways of doing the problem. But the problem itself was not a basic percent problem because we were not given the percent that we were interested in, but we could find it. Okay, so Arvin's tuition bill for last semester was $5,760. If he paid $6,048 in tuition this semester, what was the percentage increase on his tuition? Okay, so again, this is not a basic percent problem because we're not given two of the three missing pieces, right? So you need to be careful with these problems. And there's a couple ways of figuring this out. I'm going to go over the most intuitive way to figure it out. So what was the percent increase? So we want to compare the increase, and the base amount or the whole amount is always the original amount. So our tuition started at 5760. So when you're doing these percent increase problems or percent decrease problems, whatever you started with, that is going to be your base or your whole. This is your whole. But we're being asked what was the percentage increase, right? So we want to talk about the increase. So we first have to figure out what was the increase. So the percentage in the context of this problem is the increase. And so then this is where my wording and their wording is going to get a little confusing. What was the percentage increase? They want the percent increase. So I don't know why they use percentage, but they really want the percent. Maybe I shouldn't have used percentage, but I was going to do it anyway, subconsciously. So just make sure that you know that they're looking for the percent. Okay, so the percentage, we're only talking about the increase. So we went from 5,760 to 6,048. So to figure out how much the increase was, we take the 6,048 and we subtract the 5,760. So 6048 minus 5,760, tuition went up $288. But what they really want is the percent increase, right? So what percent is this, right? And so then again, the percent is equal to the percentage divided by the whole. right? So the percentage is 288. The whole is whatever you started at, 5760. And then you have 288 divided by 5760. The calculator tells me that this is a 0.05 rate, and we can write that as 5%. So I have no idea why they choose to call this a percentage. Makes more sense to call it a percent increase. Okay, so not a basic percent problem because we first had to figure out the amount that we were interested in comparing to the whole, the increase, and then it became a basic percent problem. For 3 consecutive years, the cost of gasoline increased by 8%, 15%, and 20% respectively. What was the overall percentage increase of the cost of gasoline during the 3-year period? Okay, so again, not a basic percent problem. For starters, we have 3 different percents. For second, we're not looking for the percentage, the percent, or the whole. We're looking for what is the amount of increase and what is the new amount. I'm sorry, what is the new amount? All right, so now I'm going to do the problem in 2 ways. It didn't tell us what we started at, so it did not give us a whole. And so I'm just going to make up a whole, a nice round number whole. So I'm going to say gas was started at $4, right? Even though right now we're pretty low, but well, let's say it was let's say it started at $3. For 3 consecutive years, the cost of gasoline increased by 8%, 15%, and 20% respectively. What was the overall percentage increase of the cost of gasoline during the 3 years, right? So then we can use our basic formula. So let's say gas started at $2. Sorry, $3. Nice round number. Then this would be your whole. This is what you're comparing things to, right? The percentage would be the amount of increase. So the percentage is going to be the percent, the 8%, times the whole, times the 3. So 0.08 times 3, 24 cents. So gas would have gone up 24 cents. Okay. Now the next year, when it goes up 15%, your base has changed. Your whole is changed because your new whole is now going to be, I'm sorry, this should be 24 cents. Your new whole, you started out at $3, but then you're going to add 24 cents to that. So now your next year, the amount of your increase is going to be 0.15 times the 3.24 because your new whole is going to be the original $3 plus the 24 cents that the gas increased by. And so then you have 0.15 times 3.24, 0.486. And so that represents how much your gas increased the second year. And so since you used to have a cost of $3.24, and you just went up by 0.486, your new cost is 3.726. And so then for the third increase, is still going to be the percent, 0.20, but now your whole is what the gas cost that year. And what the gas cost that year was $3.72 and 6.6. Okay. And so then when we multiply that, we get 0.7452. And so then you're going to add that to what it used to cost, and it used to cost $3, 3.726 plus the 0.7452. So your gas used to cost 3.726, and you just went through a 0.7452 increase. And so then when you add those together, you started off at 4.4712. Okay, but that's still not what it's asking, right? So what it's asking is, what was the overall percentage increase? And again, they really mean percent increase of the cost of gasoline during the 3-year period, right? So we started out at $3. Now we're at $4.47. What percent increase did we go through? So again, we first have to figure out the percentage increase. So the 4.4712, we first have to figure out the amount of increase, the 4.4712, take away the $3 that we started at, 4.4712 minus 3, 1.4712. And then we have to compare that to the original price, right? And so we're going to take 1.4712 divided by the original price, which was $3. And this will be our percent. And I get 0.4904, which is 49.04%. Now, a couple questions that you should have is, where'd the $3 come from? Does it matter? Would it have mattered had I put something else? Right? So no, turns out not to matter, because we're only talking about ratios, and all the, whether I had used $4 or not, it would all cancel itself out. And so another thing is very common for people to say, okay, we went through 8% and then 15% and then 20%. And so then people just add them straight across. 8 and 15 is 23 and 40 is 43. So they would expect that it went through a 43% increase, but that's not how it works, right? And so you need to be careful with that. But this is how it works, and we end up with a 49% increase, right? Now, if you didn't use $3, if you had used $4, it wouldn't matter. And the way I'm going to show that it wouldn't matter is by doing this problem over again. You might want to get another piece of paper. And instead of $3, I'm going to say it was P. Probably should have paused the video, but I'm almost done. So let's do the same thing all over again. Except now, say gas started at P, right? And so then if we go through a 8% increase, then the increase that first year would be the percent, 0.08, times the whole. What it started at was P. And that's it. Now we can't do anything with that. So we just leave that alone. Now, then the new price. We're going to take the increase, 0.08p, and add it with the previous price, which was p. And these are like terms, and you learned in algebra that the way you combine like terms is by adding the coefficients. So for example, if I'm doing 3x plus 4x, then 3 plus 4 is 7, and the x stays the same. And if I have x plus 5x, the coefficient here is 1. 1 plus 5 is 6x. So here my coefficient is 0.08 and 1, so this is 1.08p. Okay, and so then our next increase is a 15% increase, so we're going to do 0.15 times the 1.08p times the whole, and the whole is the original price, 1.08p. So 0.15 times 1.08 is 0.162p. And again, so now our new price is to take our old price, the 1.08p, and add it with the increase, 0.162p. And so then 1.08 plus 0.162 is 1.242p. Okay. And then we go through one more increase. And we do it the same way, the percent, 0.20 times the previous price, but this is the previous price, 1.242p. And then we do 0.2 times 1.242. Now, again, I didn't mention this up on top, but the only operation that's present in this expression here is multiplication. We have this number times this number times this number. And so we can multiply in any order we like. So I'll multiply these two together first. I do that on the calculator. And that gives me 0.248. And then we have the new price. This is just how much your gas increased. So then you're going to take the 1.242 p and add it with the 0.248. Forgot the p there. 4p 1.242 added with the 0.2484, 1.4904. So again, to combine like terms, we just add the coefficients. So we're just going to add those together, and we get 1.4904 times p. Now, to figure out the percent increase, then what we do is we figure out the amount of increase. So you ended up at 1.4904p minus p. And now, again, 1.4904 minus p is just 0.4904p. And so that's your percent increase. So then to figure out, I'm sorry, that's the amount of increase. And then to figure out your percent, you take 0.4904p and you divide it by your original price. Your original price was p. Gas started at p. The p's cancel out, and you get 49.04%. Same answer. Made absolutely no difference. And because it makes absolutely no difference, and I would like you to get a little bit more comfortable with variables, this is how I'm going to do these types of problems. If you wish, if it makes you feel a little more comfortable, you can make up a number and then use that number. So here we have another similar problem. Over the period of 1 week, the Dow Jones Industrial Average did the following. On Monday, the Dow Jones Industrial Average went down by 3.2%. On Tuesday, it went up by 11.2%. On Wednesday, it went up by 0.7%. On Thursday, it went down by 4.8%. And on Friday, it went down by 9.4%. What was the percentage increase, decrease of the Dow Jones Industrial Average over the week? Round your answer to the nearest tenth of a percentage point. So again, they're really asking for the percent. Okay, so again, we can, I'm just going to use variables. The original value we'll call P. Then we went through a decrease of 3.2%, down by 3.2%. So then the decrease is going to be 0.032. The percent times the whole times P. Okay. And there's nothing to do there. It's just 0.032P. So then new value is going to be to take P, and it was a decrease. Be careful. It didn't go up, it went down. So we subtract the 0.032P. And then again, we just subtract the coefficients. 1 minus 0.032, 0.968. But then from that amount, it went up by 11.2%. So then the increase is going to be the percent, 0.112 times the previous price, the price the day before, 0.968P. So that we can take the 0.112 and multiply it by 0.968. And we're going to get 0.108416. Okay. And so then the new value, it went up, I'm sorry, forgot the P. By this, it used to be here, and so then we add those together. 0.968P, and we add the 0.108416P. And so then I get 1.07 6416. Okay. And so then we were up to Wednesday now. Wednesday, it went up again by 0.7%, 0.7%. And so then the increase, calculate the same way. Take your percent, 0.007, Multiply it times your base amount. Don't forget the p. I forgot the p. There's a p there. We're combining, so there should be p there. 1.076416p. And so then we get 0.007534912p. So then the new value at the end of Wednesday is to add this to my previous value. So you just went through a 0.007534912p, and you're adding that to the 1.076416p. And what we have is 1.083950912. P. Whew. Okay. That was at the end of Wednesday. Thursday, it went down again by 4.8%. So the decrease is again the percent, 0.048 times where it was, and it went down off of this value, so times 1.083950912p. Multiply that by 0.048, and so then you're going to get 0.0520296438. Don't forget the p. And then your new value, you're now going to add that to what it used to be. I'm sorry, you're going to subtract it. You're going to subtract, because it was a decrease, you're going to subtract this from the 1.083950912 minus 0.0520296438. And so your new value is 1.0319. Sorry, let me go ahead and rewrite that. So what we're doing is we're taking the 1.083950912p, and we're subtracting this decrease, and we went down by 0.0520296438p. And that is going to equal, and now I'm just going to round it to 4 decimal places, 1.0319p. And then on Friday, well, we had another bad day. it went down by 9.4%. So then we have another decrease. And again, it's just the percent, 0.094 times the whole. But our previous amount was 1.03. P. And so then 0.094 times 1.0319 is just going to go to 4 decimal places, 0.097 P. This is a decrease. So your new price is going to be the 1.0319 P, and we're going to subtract 0.097 P. So the 1.0319 minus 0.097 is 0.9349. 0.9349 P. And you can see that we ended less than where we started, right? So what was the percentage increase, decrease of the Dow over the week? So again, we have to figure out the change. So then we take where we started, P, and subtract where we ended. I'm sorry, that's wrong. We take where we ended, 0.9349 P, and subtract where we began, P. And so 0.9349 minus 1, and that gives us 0.0651 P, negative. And so that tells us that we decreased. And what percent we decreased, we divide that by the original amount, and we get negative 0.0651 P, and we divide it by the original amount to figure out our percent. The P's go away, and we get that we decreased by 6.5%. So overall, we went through a 6.5% decrease from the original value on Monday. And there we go. So that is your homework from this section. This homework will be due next Wednesday. So this week we'll go over 3 sections, and those 3 sections will be due next Wednesday.